Today we are focused on the efficiency of simple machine. Exactly what it is. I want to go through one example. If this is a lever and we are trying to raise a heavy load, this is load and effort is applied at this point. If we apply effort, then certainly it turns and the load is raised to certain height. And this is the distance covered by the effort, which we call effort distance, and this is the distance covered by the load, which we call load distance. Now looking at this diagram, we can understand easily that effort means force and force is applied to certain distance. When force and distance both are involved, it means work is done in this part of the lever, and which is called work done on the machine. Work done on the machine is called work input. At the same time, a load is raised to a certain height. This load is a force, and force covers certain distance. It means again work is done because force and distance both are involved in this part of the machine also. But this work is done by the machine. That's why this is called work done by the machine, which is also called work output. It means side by side we have two work. One is work input, another is work output. The same is called work done on the machine and work done by the machine. Work done on the machine or work input can be calculated by using this equation because it is the effort times effort distance. On the other side, work output can be calculated by using this equation, work output equal to load into load distance. Now I want to define this work input and work output individually. Look at this. What is work input? Work done on the simple machine is called work input, and it is the product of effort and effort distance, and this is the formula which can be used to find out work input, effort into effort distance. And what is work output? Work done by the simple machine is called work output, and it is the product of the load and load distance, which can be calculated by using this equation, work output equal to load into load distance. Now I want to tell you that actually the ratio of work output and work input is the efficiency. That's why efficiency is defined like this. The ratio of work done by the machine, it means work output, to the work done on the machine, it means work input, is called efficiency, but it is expressed in percentage. That's why its formula is efficiency, which is denoted by eta equal to work output upon work input into 100%. This is the efficiency. But all of you know that efficiency is defined this way also. The ratio of mechanical advantage to the velocity ratio in a simple machine is called efficiency. It is expressed in percentage. Eta is equal to mechanical advantage upon velocity ratio into 100%. But how it came? I mean to say, it is actually the ratio of work output to the work input, but the same is written as MA by VR. What is the reason behind this? I want to prove this. What we are going to prove? Efficiency eta equal to MA by VR into 100%. The ratio of work done by the machine, that means work output, to the work done on the machine, that is work input, is called efficiency. This we know. It is expressed in percentage, this also we know, and according to this we can write efficiency eta equal to work output upon work input into 100%. But we know that work output is equal to load into load distance and work input equal to effort into effort distance. That's why we can write this. And then if efficiency equal to, if we take load and effort separate and load distance and effort distance separately, then load by effort can be written as mechanical advantage. That's why load by effort, and in place of this multiplication sign, if we write divide sign, then effort distance can be written in the numerator and load distance can be written in the denominator. And load by effort is actually mechanical advantage, and effort distance by load distance is velocity ratio. If mechanical advantage is divided by velocity ratio, then we'll get the result mechanical advantage upon velocity ratio into 100% is already there this way. we can prove that efficiency is equal to MA by VR into 100%. Now this formula can be used to solve the numerical problem. Not only this, we can use this original formula, work output by work input into 100%, to solve the numerical problem. Both are equally correct. Okay, let's have some question related to efficiency. What do you mean by efficiency 80% of a machine? If someone asks you this question, then you can write this way. Efficiency 80% of a machine means 80% of the total work done on the machine, that means work input, is used in useful work, but rest of the 20% is wasted due to the friction. We can write this way. Now another question, let's talk about this also. Why efficiency of a machine is always less than 100%? We know that this is always less than 100%. We can answer this way. In all the machine, a part of the work done on the machine, that is work input, is wasted to overcome friction, as a result of which the work done on the load or work output is always less than the work input. Since the efficiency is the ratio of work output to the work input and expressed in percentage, so it is always less than 100%. We can write this way. Let's go to another question also. Why work output is always less than work input? This one another important question. In all the machines, the total work done on the machine, that is work input, is not used only to overcome the load, because number one, a part of it is wasted on lifting some part of the machine which has weight. What it means? It means we can understand with the help of this. This is two-wheel pulley. We are applying effort to raise this load. But not only the load has to be raised here, but this movable pulley should also be raised upward. It means total load becomes the load plus weight of the movable pulley. That's why not only the load is raised here, the part of the machine, this is movable pulley, is also raised here. That's why a part of it is wasted on lifting some part of the machine which has weight. This is the part of the machine which has weight, and we are using force or effort to raise this part also, not only the load. Okay, next. A part of it is wasted to overcome friction of the machine. This is a very simple matter. Every machine has certain friction. Here also certain amount of friction, and because of that friction, a little amount of applied effort is always wasted. Therefore, work output is always less than work input. Okay, I want to end this class. Next class we'll meet with some other matter.